Hi, in this video, I'm going to discuss about the online support vector missions. So here, online learning means learning them incrementally, typically as new instances arrives. Simply, this process is called as a online learning. Okay, like that, for linear support vector mission classifiers, one method for implementing an online support vector mission classifier is to use the gradient descent algorithms to minimize the cost function. Okay, here we are going to minimize the cost function. Here one of the online SVM is gradient descent, like stochastic gradient descent classifier. Okay, which is derived from the a primal problem. So unfortunately, the gradient descent converges the much more slowly than the methods based on the quadratic programming. So here the equation of the linear support vector mission classifier cost function is j of w comma b equal to 1 by 2 w transpose w plus c into sigma I equal to m max of this is the cost function. Okay, max of 0 comma 1 minus t power I w transpose xi plus b. So here this is a very important. Okay, you know the value of W in the previous classes videos we discussed about what the W and what the B value, how you can find out the W and B value. In this video we are going to see the how can you find out the value of the T value that minimize the corresponding support vector mission classification. Okay. So now the first sum is the cost function. The first sum is called as a cost function. Will push the model to have small weight vector W. This is the okay. This is first sum is called as a some cost function. Will push the model to the small weight vector W, leading to the larger margin. So in the support vector machine, our aim is you have to maximize the margin between the two hyperplanes. Okay, with the help of W value, we are going to maximize the margin. Okay, then the second sum computes the total of all margin violations. So here we are going to get the value with respect to T value. We are going to get the total of all margin violations. So which elements are belong violate the corresponding margin violations. So an instance of margin violation is equivalent to 0 if it is located off the street on the correct side. Okay. Else if the proportional to the distance to the correct side of the street. Okay. Minimizing this term ensures that the model makes the margin violations as small and as few possible. So here the T plays an important role here in order to find out the margin between these two hyperplanes. So it is also possible to implement the online kernelized SVMs as described in the papers, incremental and decremental support vector machine learning and fast kernel classifiers with online and active learning. These kernelized SVMs are implemented in the MATLAB and C++. Okay. For the large scale nonlinear problems, you may want to consider using the neural networks instead of that one. Okay. So here we are having the T. Here our aim is you have to find out the T value. So the T value is going to be between the max of okay. The cost function is the function of that one is max of 0 comma 1 minus 2. Max of 0 comma 1 minus 2 is called as a hinge loss function. So that defines the margin violations elements. Okay. So now this function is called as a max of 0 comma 1 minus t is called as a hinge loss function. So here it is if the t is equal to if the corresponding value equal to 0 when t is greater than equal to 1. Okay, what are the maybe suppose t equal to here our aim is max of 0 comma 1 minus t. Okay, 1 minus t. For example, t equal to 2 value. That means max of 0 comma okay 1 minus 2, that is equal to max of 0 comma minus 1. Okay, so that is equal to in the here what are the value of t is there, automatically that becomes the max of this one is 0 only. Okay, like that we're going to find out the function value. So it is derived the slope is equal to minus 1 if t is less than 1 and 0 if t greater than 1. So it is the not differential at t equal to 1, but just like for the last row regression, we can still use the gradient descent using the subderivative of at t equal to 1, that is at any value between the -1 and 0 value. So this is about the hinge laws and online learning SVMs. If you have any questions or doubts are there, please leave them in the comment box. Okay, in the next video, I will going to address those problems or doubts. Okay, thank you for watching our video. If you like the video, please subscribe my channel. Thank you.